So day 5, we have 2 topics for today. Our first topic that we're going to talk about is distance, and then we're going to talk a little bit about midpoint later on. So for distance, when I am talking about distance in geometry, you've probably heard of the distance formula. Maybe you remember it, maybe you don't. It's a long formula. It is not one that I prefer to keep memorized at all times. So instead, what I like to do is we like to think about distance in geometry as Pythagorean theorem. If I'm looking at a graph specifically, it's very easy to see this Pythagorean theorem going on. So if we look at this graph on the left here, I have 2 points, A and B. That segment in red represents the distance between them. Rather than try and figure that out using my distance formula, I draw a right triangle by connecting them up horizontally and then vertically. So do we see these parts in here? Hopefully. In order to make a right triangle and connect these things up horizontally and vertically, basically what I'm doing in this corner here of this triangle is I am making a right triangle. Right down in the corner, this is a right angle down here. So because that's a right angle, I can use my Pythagorean theorem, and I'm going to count up the lengths of these sides. 1, 2, 3. Horizontally, that distance is going to be 3. I could also do it by subtraction. I know that this is at 6 and this is at 3. 6 minus 3 gives me a length of 3. Same thing vertically, right? I have my vertical 4 spaces. If we wanted to use subtraction to do that, I could do 6 minus 2 and get 4. Now to find the distance, that hypotenuse of that right triangle, I use Pythagorean theorem. We know Pythagorean theorem, right? A squared plus b squared equals c squared. And plug my values in. 3 squared plus 4 squared equals c squared, where c is going to be that distance, that hypotenuse. 25 equals c squared. Remember, in order to get rid of a square, we square root both sides. The square root of 25 is 5. And we know, hopefully from algebra, that anytime you square root both sides, you got to think plus or minus. But we don't need the minus version, the negative version here. Because we're talking about geometry, we know that the length of that hypotenuse is not going to be a negative number. So that distance would be 5, right? So now let's think about that in terms of variables. Rather than thinking about it in terms of numbers, what does that look like for variables? Well, that horizontal distance that I found earlier, right, this in blue here, maybe, if you want to draw, there we go. What I did was I took the x value of my b minus the x value of a, aka, if I want to put that in variables, x2 minus x1, right? And that became the length of that side of my triangle. Then I did the same thing vertically. I took the y value of point B minus the y value. Something is going on with my pencil today. Minus the y value of point A, this guy right here. And I got y2 minus y1 as my vertical distance. Now if we set that up, keep setting that up in the Pythagorean theorem, we know that that means that my distance d squared looks like that. So that's like my setup for Pythagorean theorem. What is going on with this thing today? So here's the distance formula. Maybe you've seen it, maybe you haven't. I say, I don't like memorizing it. I don't want you to memorize it. Instead, let's think about where that distance formula comes from. It's a bunch of x2 minus x1, y2 minus y1. Well, those things all look familiar. We just did that. It's Pythagorean theorem. The only thing that is different between here and here is that instead of having d squared on the end, I square rooted both sides. I got d by itself. D equals the square root of essentially all this Pythagorean theorem stuff. So that's where that's coming from, and I recommend that that is what we are remembering. What is all of this stuff? This comes from Pythagorean theorem. Any questions on that? Okay, so moving on. The next topic we're going to cover is midpoint. So for midpoint, again, there's a bunch of fancy formulas that we don't necessarily need to have memorized. If we think about midpoint of something, it's going to be halfway in between the x's, halfway in between the y's. So the easiest way to remember this is it's always going to be an average of the x values and an average of the y values. And hopefully we remember how to find an average, right? We take a bunch of things, we add them together, we divide by the number of things we added together. So for a midpoint, if I'm finding the midpoint between 2 points, that's going to take this form. I add up all of my x values together, x1 plus x2. I divide by 2. That is going to give me the average of the x values, aka the x coordinate of my midpoint. Same thing for the y's. I can take y1 plus y2, those are my 2 endpoints, and divide by 2 to get the y coordinate of my midpoint. So think about averages. We're going to do some practice on that in a second. But let's go back to the distance formula. And what is going on? Okay. So find the distance between A and B. This time I have a graph. I don't always have a graph, but it's kind of nice to visualize when I do. So let's go ahead and plot A and B on here. A is at 3, 4. And B is at -2, -5. Connect those up. And let's call that length D, that distance D. So I want to figure out what that is. It's a slanty line, so I can't just count the boxes, right? I have to use Pythagorean theorem. So I am going to take my box here. And I'm going to connect them up horizontally. So starting with B, I'm going to go all the way over. And then with A, I'm going to go all the way down until they connect up. Can we see that? So all I got to do now is count up the boxes for the side lengths. So from B, I have 1, 2, 3, 4, 5. And A over here on the vertical side, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have a triangle, right triangle, with side lengths 5 and 9. So in order to find that distance, aka the hypotenuse of that triangle, all I need to do is use those values in the Pythagorean theorem. 5 squared plus 9 squared must be d squared. 25 plus 9 squared, plus 81 equals d squared, which is 106 equals d squared. I can get that by itself by square rooting both sides. In exact values, I could just leave that as the square root of 106. And if I wanted to round, which sometimes I do want to round, 10.3. Your math lab is going to be a little bit picky about what it wants, what it expects in terms of your answer. So just pay attention whether it wants exact values or rounded values. Any questions on that? Okay, so then sometimes we get a little bit tricky because we don't have a graph to work with. Sometimes we just have the points, and that's okay. We're essentially doing the same thing here. If I think about what happened, I found the horizontal distance between B and A, and I found the vertical distance between B and A. And that ended up being the two sides of that right triangle. So here, with the points, horizontal distance is represented by those x values. So So the distance between the x's. What's the distance between the x values of E and F? Those x values are -4 and 3. What's the distance in between them? Between -4 and +3. Oh no. Caitlin, you know? Yeah, it's 7. I'm literally counting, right? The distance between -4 and 0 is 4. The distance between 0 and 3 is 3. 4 plus 3 is 7. If you want to think about it in terms of absolute values, you can. I don't know why you would do that. That might be a little bit crazy, but you absolutely can. Remember that those should never be negative numbers. We should never have a negative distance. So if you have a negative distance, you did something wrong. Then I do the same thing for vertical distance. I'm thinking about the distance between my y values. The y values here are 1 and -1. What's the distance between 1 and -1? Count them up on a number line. It's 2. So now in my head, in my imaginary triangle that I don't have drawn, I know that the sides of that triangle would be 7 and 2. So I'm going to use those values, 7 and 2. Oh my goodness. And I'm going to use Pythagorean theorem. I believe I get 53 equals d squared. Square root both sides. D equals the square root of 53. Or I think it was like 7.3 as well here. Okay. Any questions on the distance formula, aka Pythagorean theorem? Okay. Go to the next page. Look at midpoint stuff. I'm going to rewrite all of that midpoint stuff that was on the last page right here, just so that we have it right at the top. So for midpoint, usually our midpoint comes with a letter to use for the midpoint. A lot of the times midpoint is represented by an M. That's just the name of the point. So the coordinate of M is going to be the average of the two x's for my endpoints. That's represented by x1 plus x2. All over 2. And the y coordinate of that midpoint is going to be the average of the two y values for my endpoints. y1 plus y2, all over 2. So if I'm looking at number 3, it says find the coordinates of M, the midpoint of GH. For G and H, I have those two endpoints. Then all I have to do is literally plug those endpoints into these formulas. My midpoint called M is going to be the average of x1 plus x2. Remember, we have x1 and x2 in here. x1, x2, y1, y2. So M is 8 plus, we're always adding when we find averages, -14, all over 2. For the y values, it's the average of the y values of my two endpoints, -6 plus 12, all over 2. And then we're literally just simplifying. So I take those values. 8 minus 14 gives me -6 over 2. -6 plus 12 gives me +6 over 2. So the coordinate of my midpoint, simplified, is -3,3. That's it there. Any questions on that? As long as we can remember how to find an average, I think we got this. So then it gets weird, because then we get a problem like number 4. What's the difference from number 4 compared to the one that we just did? We're doing something different in number 4, right? We don't need to find the midpoint. We already are given the midpoint. Instead, this time we're finding an endpoint. So in order to find an endpoint, we're going to set it up the same way that we did this guy right here. I'm going to set up the midpoint is the average of my two endpoints. So let's start. I know my midpoint is called E. E is the midpoint. And I know that midpoint is going to be made up of the average of my two endpoint values. My two endpoints are D and F. I know what F is. I have X1 and Y1. But I don't know what D is. So that X2 and Y2 is just going to be left exactly like that as X2 and Y2. So let's fill in the blanks here. The average of the X values, X1 is -5, X2 we don't know, all over 2. The average of my Y values, Y1 is -3, Y2 we don't know, all over 2. And now I'm kind of set up here. But I do know what each of these pieces is supposed to equal. The X value of E is supposed to be -6. So I'm going to set that piece up equal to -6. Right? That's coming from right here. And I know that the Y value of my midpoint is supposed to be 4. Do we see where those values are coming from? Okay. So now we're just going to simplify and solve for those missing pieces. So -5 plus x squared over 2 equals -6. I'm going to multiply both sides by 2. And I'm going to add 5 to both sides. So this is going to be a -7. And I'm going to do the same thing with the y's. I multiply both sides by 2. I add 3 to both sides, I get 11. So D, that end point that I was not sure about, we know that that has to be at -7, +11. Any questions on that? Do we think that we can try 5 on our own? Okay, go ahead, take a couple minutes and try number 5. Okay, let's think about this coordinate. I know N is the midpoint, so that's what I'm going to start setting up. N is going to be the average of my two endpoints. So S is my first endpoint. R is my second endpoint that I don't know. So I start filling some stuff in. I want, for my X values, X1 is -1 plus X2, I don't know, all over 2. Y2 and Y1 are 5 plus Y2, all over 2. Okay, now I need each piece. What am I setting this side, my X values, equal to? Casper. Yeah, 8, the X value of my midpoint. It always equals the midpoint, right? So -1 plus X2 over 2 equals 8. This should give me -1 plus X2 equals 16, or X2 equals 17. And I do the same thing over here for my Y's. 5 plus Y2 over 2 equals what? Anna? Perfect. And 5 plus Y2 equals -6. Y2 equals -11. So the coordinate R that I was trying to find should be at 17, -11. Any questions there?